3D printing. So as we all know, the additive manufacturing is a very important topic in this coming the future area. So in this, we need to excel in manufacturing, as well as this area is also good for the research. So the subtitles of the topic that I will cover in this presentation will be recent advances in engineering and manufacturing, smart manufacturing, additive manufacturing, opportunities and applications of 3D printing, challenges associated with 3D printing, benefits of 3D printing, classification of additive manufacturing processes, and discussion on some commonly used 3D metal printing techniques. So after this, practical session will be taken by my fellow colleague, Dr. Praveen. So we all know that the manufacturing, there is a big development or advancement in manufacturing scenario nowadays. It is taking place because of IT and AI and machine learning. We all know about these things. A rapid advancement in manufacturing technologies, operations, business models is taking place across the globe to address the emerging manufacturing and business challenges. The rapid advances encompasses various aspects, including, so we know the digital transformation is taking place in a big way. So integration of advanced technologies like Internet of Things, artificial intelligence, machine learning, big data analytics to streamline operations, enhance productivity, and preventive maintenance. So basically, smart manufacturing, world-class manufacturing, this additive manufacturing. So all these are the components of the Industry 4.4, Industry 4.0 implementation. So implementation of Industry 4.0 principles with adoption of automation, cloud computing, and Internet of Things create the smart factories that uses these smart manufacturing concepts. So really interconnected with and market driven. So lean manufacturing is also important from the point of view of increasing the productivity, etc., etc. So applying lean methodologies such as Six Sigma, Kaizens, just in time to optimize the processes, reduce waste, improve efficiency, and enhance overall production quality. So sustainable manufacturing is again an important aspect, so that takes care about the environment. Incorporating eco-friendly practices, renewable resources, and energy-efficient technologies in manufacturing contributes to minimize the environmental impact. Agile manufacturing, so developing agile manufacturing processes and strategies allow quick adaptation to market changes, disruptions, or ever-changing customer demands. So we all know that the customer demands are always ongoing, changing process. So the agile manufacturing is able to meet the customer needs as per their requirements. So 3D printing and additive manufacturing, adoption of this process is very useful in rapid prototyping, customization, and production of complex parts or the components. So this is how the advances in manufacturing are taking place, and 3D printing is a part of this newer advancement in manufacturing. So people talk about a number of things about world-class manufacturing, smart manufacturing, etc., etc. So most of the industries organizations worldwide are in effort to excel in manufacturing and business performance. So further, we have to deal with manufacturing excellence and the business excellence. So manufacturing excellence means it deals with the plant performance, zero breakdowns, zero defects, zero accidents, etc. So while the business excellence means the higher profits, productivity, customer satisfaction, dealer satisfaction, etc., etc. The manufacturing organizations worldwide are experiencing a radical change because of the following. So there is advances in products and process technologies. So the products as well as the processes, so they are advancing in a very rapid way. So higher and ever changing customer expectations. So customers' expectations are also continuously changing with the lapse of time. So because of the global and the competitive market, again, there is a cutthroat competition to reduce the manufacturing cost, good, better quality, and add on new and new features, etc., etc. So therefore, the organizations are required to progress at a faster rate than their competitors using world-class manufacturing practices. So under this world-class manufacturing, there is the concept of smart manufacturing. Smart manufacturing refers to the use of advanced technology and data analytics to improve the efficiency, productivity, quality, and flexibility of manufacturing processes. It involves the integration of various cutting-edge technologies such as automation in manufacturing and business operations, Internet of Things, artificial intelligence, machine learning, robotics, 3D printing, etc. So these technologies may help to produce the goods more efficiently with higher productivity across the value chain. So that is why there is a big importance of 3D printing. And this course is very relevant in giving the information to the participants, either to have discussion with the students on this 3D printing, as well as if somebody is interested to adopt this as a research area for their PhD or MTech thesis. So this course will be very, very beneficial to them. What is additive manufacturing? Additive manufacturing, commonly known as a 3D printing, is a revolutionary manufacturing process. So that adds successive layers of material to create a final product using digital 3D models. So this technology has gained significant attention due to its versatility, cost effectiveness, and potential to transform in manufacturing and other applications. 3D printing has significantly transformed engineering and manufacturing processes across various industries due to its unique capabilities. So the future manufacturing process will be the additive manufacturing for the industrial sector. So if we compare the additive manufacturing with respect to subtractive manufacturing, so how this is better than the subtractive manufacturing? So in case of subtractive manufacturing, there is initially a material is available with us. So on this material, we have to perform some manufacturing processes or machining, etc. So that removes the material in the form of chips. So from this block, you see a good amount of the material has been removed. So that material will be the waste, and the final product with limited material as compared to the initial available material will be used as a final product. So in case we will use the additive manufacturing process, so we'll take a small amount of the material, we will process it through additive manufacturing, and the final product will be made available like as is being created by the subtractive manufacturing. So, but in this process, the waste is very, very minimal. So therefore, this process is able to save a lot of waste which otherwise is being produced by the subtractive manufacturing. So how this additive manufacturing process works? So initially, we have to create a 3D CAD model using some softwares available in the market. So this 3D CAD data is cut into numerous sections, and these sections are printed one over the other. to get the final component. So this additive manufacturing process works like this. This is the this is the STL file available on the system. So through this, the feedback is being given to the printer. So this printer will work to deposit the layers layer on layer, and the final product will be prepared in a short duration of time. So again, this figure also depicts the AM process. So the first step is designing the CAD model. Second is this CAD model, which is a 3D model basically, is being cut into the slices so that those slices may give the instructions to the printer to deposit the layers over the layers, and the final product will be made available. So third step is printing of the part through AM process. And finally, if some post-processing is needed, that can also be done on the printed component or the part. So that is how this process works. So this is again the same thing. So first, through scan, we can scan the 3D object. From that, we can prepare the 3D model. Then the slicing is being done. After slicing, so through this printer, the printing is being carried out. So that is how this 3D printing process works to create some required components or the parts. So this is a small case study which just gives the advantage of using the AM process. Suppose we have to create a bottle opener through this additive manufacturing process. So if we have to use the conventional machining process, we will first use this block bar. From this bar, we will perform some machining processes, and the final product will be like this. But in case the bottle opener is being created by the 3D printing, so this will be the final product. So here you can see a lot of material is being saved, as well as this process is fast. So here you can compare. So the weight of this opener is only 0.95 grams, whereas this item is having the weight of 4.22 grams. So there is a big saving in the material if the product is being made by the additive manufacturer. So here the second example is there. This is the buckle being used in the aircrafts to tighten the belts. So again, if this buckle is being created with the 3D printing process, then the total weight may be only used as a 68 grams as compared to 155 grams that is being used by the conventional process. So there is a big saving in the material as well as the time, and as well as this is having the more strength, and that is again the added advantage.
Sir, one question. What about the strength part?
Because when we are designing this product, so all those things, the stress, its fatigue, impact strength, etc., being taken care of. So naturally, the components being fabricated with the additive manufacturing process, so they are better than the parts being manufactured by the conventional machining process. So all these things are being taken care during the designing of the 3D model of the additive manufacturing parts manufactured.
Okay, sir.
Okay.
Okay.
So now we will discuss about the opportunities of utilization of 3D printing. So overall 3D printing technology continues, and its application in engineering and manufacturing are expanding rapidly. offering new opportunities for innovation and efficiency across numerous sectors. So as you can see, there are a number of possibility of applications of the 3D printing. So it can be used in making the prototypes, toolings, and jigs used in industry. So even the supply chain optimization, repair and maintenance of equipment, automotive and aerospace में इसका बहुत है, customer goods, product customization, low volume, product production. So it is very useful technology when we need only a few components. That is the low volume product production. So material innovation, building construction and architecture, education and research. So it has wide applications in these areas. So the foremost important area of application is the rapid prototyping. So 3D printing is being used in rapid prototyping as one of the earliest and the most widely used application of 3D printing is rapid prototyping. So engineers can quickly create the prototypes of parts or the products, enabling faster iterations, design validation, and reducing the development time and costs. So this is how this rapid prototyping is being used. So first of all, the design is there, then is being manufactured by 3D printing. And after 3D printing, this final product is available. This prototype is available. So once this prototype is being approved, then this prototype will be accepted to go for the mass production. So this is a very time-saving process. So customization. So 3D printing can be used to customize the products. So those may be needed in various areas. So first of all, for example, this is healthcare. So in healthcare, if somebody needs some plaster or some extended part of the body, so that can be fabricated with the 3D printing as per the size required for the specific person. So these are the examples. So that is being used in the healthcare section. So again, in medical, so some components can be fabricated by additive manufacturing. So in dental, so 3D printing is being widely used in dental applications, in preparing jaws and some implants, etc., etc. Even in hip bones can also be created with the 3D printing process. So construction and architecture. So in this area also, the 3D printing is now is advancing like anything. So the bridges, some houses, and some small scale models of the buildings can also be created with the 3D printing process. So in food industry, 3D printing is finding its applications in making the cakes. So the 3D printing is being used for making the layers of the chocolates or the cream over the cake. So where we need only a few components, low volume production. So in that case, this 3D printing is very helpful. So for example, this is a case of the movie props. So where some props have to be created. So this additive manufacturing technology can be used to create a few items as per the requirement. So next, the 3D printing is finding big applications in automotive and aerospace industry. So these industries benefit from 3D printing for lightweight and complex parts, enabling design optimizations that can improve fuel efficiency, performance, and reduce overall weight. So in case of the aircraft, so this total assembly can be created with the help of the additive manufacturing. So 3D additive manufacturing is finding a big applications in aerospace. So whensoever some space shuttle is being launched, the 3D printer is going along with that. So that if any damage takes place, damage of any component will take place during the journey. So then it can be fabricated by making use of the 3D printing process. So it has a good applications in aerospace industry also. So you can see in space shuttles, the printers are being used to make some products to maintain the spacecrafts, etc., etc. So in making some customer goods like fashion industry, the dresses can be created. Some special dresses can be created by making use of the 3D printing. In making some jewelry items, so this technique can be used for making some very innovative jewelry items. So customer products like your mouse or the cover of the mobile phone, some intricate parts or decoratives can also be created by making use of additive manufacturing process. So these are the some specialties which can be used in our homes. Some other applications. So this additive manufacturing can be a very useful technique in optimizing the supply chain. So it allows for decentralized manufacturing by enabling the production of the parts or the components closer to the point of use. So suppose I need a component to be used in Chennai. So then there is no need of constructing that component in Punjab. So that can be made, fabricated near to the location where it has to be used. So give and mitigate risks associated with centralized manufacturing. So in education and research area also, this 3D printing is finding wide applications. So 3D printing has become an essential tool for educational purposes and research institutions. It allows students and researchers to experiment, visualize complex concepts, and develop prototypes for various experiments and studies. We'll talk about the challenges which are associated with 3D printing or the additive manufacturing. So first very limitation is the materials limitations. So the conventional materials available, so some materials cannot be used in 3D printing because of the strength issues and some finishing issues, etc., etc. So the range of the materials available for 3D printing is still limited compared to traditional manufacturing. So developing more diverse and high performance materials suitable for different applications remains a challenge. So this opens up new possibilities for developing advanced composites, metals, ceramics, and biocompatible materials to be used for creating parts with enhanced properties tailored to specific applications. So quality control is also an issue. Ensuring consistent quality across 3D printed parts is crucial, especially in industries like aerospace and healthcare, where precision is paramount. So controlling factors such as porosity, layer adhesion, and surface finish remains a challenge. So these are the main issues: porosity, to control porosity, layer adhesion. Sometimes the 3D printed parts may not be as strong as is being created with the conventional machining because of their bonding between the layer to layer bonding and surface finish. So these are the big challenges. So speed and scalability. The speed of 3D printing, especially for the large or the complex parts, remains relatively slow compared to traditional manufacturing methods. So improving print speeds while maintaining accuracy is essential for broader industrial adoption. Post-processing requirement after printing parts often require post-processing to achieve the desired properties, adding time and cost to the overall manufacturing process. So this post-processing again adds on the cost as well as it involves some time. So we can say that the manufacturing time is also large as compared to the conventional machining process. Cost of equipment and materials. So initial investment costs for the high quality 3D printing equipment can be significant. Additionally, some specialized materials used in additive manufacturing can be costly. So intellectual property and regulations, as 3D printing becomes more accessible, concerns regarding intellectual property infringement and the need for regulations to govern its use, especially in fields like health, are growing. So 3D printing, so we know a number of benefits are there. It gives us some financial benefits as well as some technical benefits. So if we are talking about the financial benefits, so the first one is getting products to the market at the faster rates. 3D printing organizations can quickly and affordably produce prototype functional parts. So once a design is prepared, this technology can be used to produce the tools, fixtures, and other parts that can produce products at the faster rate. By shortening the product development cycles, organizations can generate more revenues. So basically, it makes the production processes faster. Reducing manufacturing cost. Manufacturing of the components require skilled labor, advanced machines, and traditional tooling that involves higher costs. Metal 3D printing increases flexibility in manufacturing and allows for producing complex parts with ease, and thus helping organizations to produce parts at more affordable price. Replacing insufficient manufacturing workflows. So 3D printing metal parts will help organizations become more dynamic and responsive. So in terms of the technical benefits we are getting from 3D printing is ability to design geometrically complex part. So as we know, the 3D models can be created by making use of SolidWorks, etc., etc. This gives the ability to design very complex parts with ease, ability to manufacture parts without tooling. So in 3D printing, so we don't require any jigs, fixtures, or special tooling. Even no cutting tools are required. So therefore, so this reduces the use of the additional tooling. Ability to produce parts without detailed drawings or CAM. So if we talk about the conventional machining, so in that case, we need the detailed drawings, the CAM, computer-aided manufacturing, etc. Whereas in 3D printing, so all those things are not required. So these processes differ in their techniques, materials, and applications. Here is a classification of some of the commonly used additive manufacturing processes. So we can classify these processes as per the use of the different machines and the materials for those machines. The first one is the SLA, that stands for the stereolithography. So this process basically uses a UV laser to solidify layers of the liquid, getting precise and objects. It is widely used for the high resolution prototyping and intricate designs. So in this process, the materials that those can be used are the photopolymer resins with various properties like standard, flexible, castable, etc. So this process is having the applications in high resolution prototypes, dental models, jewelry, and intricate designs. The second one is the digital light processing. So again, it is a kind of a wet polymerization process. So it is similar to SLA process, but uses a digital light projector. So in SLA, we are making use of the UV laser, but here this process is using a digital light projector to cure entire layers simultaneously. It is faster than SLA, but may have slightly lower resolution. So in this process, the material that can be used is similar to the photopolymers that those are being used in the SLA process. So again, the applications, prototyping, jewelry, dental applications, and production of the detailed objects. The second category of the processes comes under the heading material extrusion. So it is a kind of an extrusion process. The first process that is being used is fused deposition modeling, FDM process. So basically in this process, we are making use of the filaments. So that is being extruded through a nozzle, and then layer to layer is being deposited in the chamber. So that is being used to create the 3D models or the objects. So most common and the accessible method, extruding thermoplastic filaments through a heated nozzle layer by layer. FDM is used in various industries for prototyping, tooling, and end-use parts. The materials those are being used in this process are the polylattice acid, PLA, ABS, and some other thermoplastics. The applications: prototyping, manufacturing, functional parts, educational purposes, and hobbyists use. The next category is the pellet extrusion. So it is similar to the FDM process, but the only difference is in this process we are using the thermoplastic filaments, but in this process we are using the thermoplastic filaments. So but uses plastic pellets instead of filaments, offering potential cost saving and material diversity. So here the mixing of the pellets is possible, so therefore we can make use of this process in a better way as compared to the FDM process. So the third category of the process, additive manufacturing, is powder bed fusion. The first one is selective laser sintering. So this process utilizes a high powder laser to selectively fuse powdered materials like plastics, metals, or the ceramics. Layer by layer, it is suitable for functional prototypes and end-use parts with good mechanical properties. So in this process, the materials which can be used may be the nylon, polyamide, metal powders. For example, it may be aluminum, titanium, etc., and the ceramics. Applications: functional prototypes, end-use parts in aerospace, automotive, and medical industry. Direct metal laser sintering, DMLS, or you can say the selective laser melting, SLM process. So this works with the metal powders, melting them using a laser to create durable metal parts commonly used in aerospace, automotive, and medical industries. The materials those can be used maybe the various metal powders like titanium, aluminum, stainless steel, etc. So it has the applications in aerospace, automotive, medical implants, and high strength metal parts. The next category of the AM processes is binder jetting. So as the name suggests, it involves spreading a powdered material layer by layer and selectively jetting a binder agent to solidify specific areas. So it is used for the metal, sand, and ceramic printing, primarily for creating the complex parts and molds. The materials that may be employed in this process are metal, metal powders, sand, ceramics. So this can be used in making metal casting molds, prototypes, sand cores for the foundry applications. Material jetting. Material jetting is similar to the inkjet printing process, but uses materials such as photopolymers or the waxes. It precisely jets droplets of the liquid material onto a built platform layer by layer and is used for high resolution multi-material prints. The next one is the directed energy deposition. So this process uses a focused energy source like a laser or electron beam to melt and fuse materials as they are deposited. So this process is suitable for the repair, cladding, and creating large complex parts, particularly in the aerospace and automotive sectors. The next one is the continuous liquid interface production. So this process is the continuous liquid interface production technology that combines UV light and oxygen. So here we will discuss about the process that is being used in the direct metal laser sintering process. So here you can see in the middle this portion. So this represents the fabrication of the component or the part. So initially, so all these three platforms at one level. So this is the build position of the platform, which is being going down after layer to layer deposition. So these are the powder feed position. So these stations allow the feeding of the powder. So first suppose karo, the powder is being supplied through this channel on this table bed. This powder is being spread by making the leveling roller over this surface. So after laying the layer of the metal powder, so the laser beam is being impinged on the area where the melting is needed. So after impinging the laser beam, so this specific metal powder will melt and a solid layer is being created. So after this layer formation, so this bed will go a little down as per the layer thickness, and the roller will be on this side. So the next, the powder is being supplied through this channel and the leveling roller will move in that direction. So again, a layer of the layer of the metal powder is being layered over this surface, and after that, this laser is being hit over the area to be layer to be deposited. So this way, this roller will move from this to this direction, and layer to layer will go on depositing with the progression of this table downwards. And finally, we are able to create the 3D object or any component as per the design part. So this is how this direct metal laser sintering process is being used to make the components or the parts used for any other applications. So this figure depicts the binder jetting process. So again, we'll make use of some chamber like this. Here a platform is there. So over this, so it is in two sections. So one component, one platform is going downwards. So this platform is being used for the supply of the powder. So initially these two platforms are at the same level. The powder is being supplied through this. This leveling roller will lay a layer over this table, and this binder liquid adhesive supply is being supplied from this chamber like this. So this will spray a layer of the binder, or you can say adhesive, and when this layer of the powder will come in contact with this adhesive, so the solid layer will formulation of the solid layer will take place. So slowly and slowly a number of layers can be laid to create the final product. So slowly and slowly this build piston or build chamber, so it will go down, so it is stationary, and the final product will be made available for use. So these are some of the examples that are being created with the help of the binder jetting process. So in welding area also, this wire arc additive manufacturing. So again, it is a kind of additive manufacturing process. So here in this process, the wire is being so wire arc additive manufacturing, it is a kind of a welding process basically. So in this process, we are making use of the robot. So this robot is being configured to make layers to layer. So here in this figure, you can see a number of layers are being laid to make this block. So in this, we can make use of stainless steel, nickel-based alloys, titanium alloys, and aluminum alloys. Some special metals can be used for making the end products for some specific applications. So with the help of this robot, so this is being using a tungsten electrode, and a metal wire is being coming to the hot area. So this weld pool is being created, and we can make use of laying the layers like this. So very complex solid components or maybe walls can be created by making use of this process. So basically at SLIET Longowal, we are having this machine with us, and a good number of people are working for their PhD thesis as well as some MTech thesis are going on in this machine. So this is a metal fused filament fabrication process. So in this, we are making use of the filament. So this filament can be either of metal or maybe some polymers also taken. So in this filament, the wire through the filament wire is being drawn to this heat chamber. So after that, the molten metal is extruded through this nozzle to deposit layer to layer on some built platform to make the final product. So metal fused filament fabrication. So at SLIET Longowal, we are having additive manufacturing lab with us. So this is a printer which is Ultimaker. So in this printer, there is a facility to fabricate the polymer filaments as well as the metal filaments. The metal printing as well as the polymer printing can be done with this printer. So here you can see, so this cube of some of metal, that is copper, is being fabricated with this process. So in this metal printing, basically, again, because the layer to layer is being deposited, the filament is being coated with some flux kind of layer, outer core. Okay? So that is not giving a very strong adhesion between layer to layer. So after this, we have to perform the sintering process so that the strong bonding between the metal components, metal parts have to be taken place. So this is the 3D printed metal 3D printed part. So that is being sintered for some duration of time at specific temperature. So that is how. So this metal printer is being used for printing the metal parts. So, so this was all about my discussion on during this presentation. The second practical session will be taken by Mr. Praveen Kumar.
Yes.
Now I hand over I request him to please continue this session so that after the completion of the session, we can have some queries session if anybody is having any query. So we are able to. Thank you so much.
Thank you very much, sir.
Okay.
सर अपनी स्क्रीन को अनशेयर कर ले.
Okay.
Hi, good morning, everyone. It's a very informative lecture from Dr. Pardeep Gupta. I'll continue the rest of the session. In the last, sir has told about the metal fused filament fabrication. So I'll continue that technology practical session from scratch to the final product. We'll see how the final product will be look like. So before I start, we collect the data and we create a solid model of the object. So I have made a video. So accordingly, I will speak over this. For the solid modeling, we can use the SolidWorks and Arcadia and other modeling softwares. So we have here we have 20 cube we have designed, and that 3D model we just save into a STL format. Here you can see the 3D model. We have recently modeled through the SolidWorks, but we can also, if we don't know the how we need to modeling the model So we can download these models from the websites. Here I can tell you some other websites too. Just wait. The one of the website is thingswords.com. Here you can find the uh, 3D models of the other objects, and here there is 1 lakh objects are there. There you can find the STL formats of those objects. So if you don't know how to model the 3D model, so here from this website you can get those models. So after modeling, we just save the file into the STL format, and that STL format file we just upload into the slicing software. From the slicing software, we just cut the slice the object into the many layers. So I'll show you. The one of the famous slicing software is Ultimaker Cura software. So this software is I have already downloaded, and I have already uploaded that STL file from that I have model from previous one. So from this, I'll tell you this from the scratch point of view. Uh, from the laptop side, you can see the number of printers, and you can add your printer too by clicking on the add printer. When we click on the add printer, we got some options like add network printer or add non-network printer. uh, Please go to the add non-network printer. Here you can find the number of various brands printers are already listed in this slicing software. So you can choose your brand, and accordingly you can register your printer into this slicing software. Like we have Ultimaker S5 in our laboratory, so I'll choose this Ultimaker S5, then I'll add this. So the Ultimaker S5 is already added. After that, we need to just upload this STL file. I can show you how I have uploaded. File, then open file, downloads. This is the 40 STL format file, and this is I have uploaded it. After this uploading, as Ultimaker S5 is twin extruder, means it has two nozzles. So we need to define from which nozzle we have to print. So from this point of view, we can see here there are two nozzle, 1 and 2. You can enable either 1 or 2, or if you want to print with the different colors, so you can enable both the nozzles. So one layer can be printed from other nozzle, and one can layer can be printed from the second nozzles. So I mean, this nozzle, you can choose the material too. Like here I have chosen the PLA material. You can use the other material like ABS, nylon, PC, PETG, PLA, and other materials. And beside with this, we have to mention the print core. Print core means the nozzle what we are using. Here we have already chosen the AA 0.4. 0.4 is indicating the diameter of the nozzle. Here you can use this 0.2 diameter nozzle, and here you can use this 0.8 diameter nozzle. And AA defines the nozzles material. Like AA is used for the polymers, BB is used for the supporting materials, and CC is carbon core, and that is used for when we are extruding the some reinforced material like metals, carbon fibers, glass fibers. So these carbon core nozzles are different from these materials, these nozzles, because when if we use the simple nozzle for extruding the metal wire, so the metal powder and the metal wire will start eroding the nozzle. So we need to have better quality of this nozzle. So carbon core material is they have placed some ruby core material on the that nozzle. So we have to use this carbon core. And another type is DDD. So here this is all about the nozzles. So how we can use this. And now come to the parameters point of view. Some here are some already they have designed this profiles. If you want to use the extra fine material, extra fine quality, you can use the 0.06 mm layer thickness. If you use the fine type of quality, then you can use the 0.1 mm thickness. And so we have different thickness profiles are already available. In these profiles you can see you can vary the quality of this object. You can change the wall thickness, you can change the top and bottom layers, you can change the infill, you can uh, change the material, about the material, like on which temperature you have to print. And you can change the speed of the nozzle, you can change the travel speed of the nozzle, you can change the cooling part. And you can also add this support and all, and build adhesion type. So one by one we can see these type of subparameters. In quality, you can here you can see this layer height. If we choose the layer height as 0.15, uh, and top and bottom layers are this zero point 0.4 and zero point 0.4. So accordingly, if as per experimentation, you can change these parameters according to your requirements. If here you can see the walls types, the wall thickness is 0.8 and wall line count is 2. So accordingly, according to your experimentation, you can change those wall line count and wall thickness too. Now come to this top bottom layers. uh, Top surface skin layer is one. uh, just keep in this mind, where I'll show you how this surface skin is look like. And top layers are 7, bottom layers are 7. So according to your experimentation and requirement, you can change these parameters. And infill, here right now it is in 20%, and you can place it to 100%. So I will show you the difference between 20% infill and 80% in 100% infill. So here the infill pattern is zigzag. We just switch into the lines. And the material, the PLA is generally melting at 200 degree temperature. We use the nozzle temperature as 200 degree, and build volume temperature is 28, and the bed temperature is 60 degree. So there is no overhang part, that's why this function is not working here. Okay, now just slice it. I'll show you how this gonna work. From the blue part, you're seeing it. This is our brim. When we are adding the first layer on the surface of this build plate, it won't stick to the surface. So keep the object adhesive to the surface of the build plate. So we need to add this brim. This is the only single layer of the material, and it will keep the object keep adhesive to the build plate. So here you can see the first layer, the red one, this is the outer layer of the object, and the green one, uh, this is the inner layer of the sorry, not inner, this is the middle layer of the object, and the yellow one, this is the innermost layer of the object. So these three layers, when we combine all this is the wall thickness of the object. And in between this layer, they are and the pattern is line. So they are all inclined at 45-degree. So this is the first layer. When we cross to the second, third, fourth, up to seven, we have already set it, the top bottom layers are seven. So up to seven layers, this all will be filled. And after that, there's infill pattern will start on eighth layer. So this is how the orange part is our infill. So we have taken that 20% infill. So this is the 20% infill part. So it will keep on going, and the pattern is zigzag pattern. And as it goes to the up, the uppermost layer 7 would be the 100% infill. The remaining, the topmost 7 layer would be the 100% infill pattern. So these can also be changed. So here you can see these layers are aligned horizontally and parallel to the base edge of this object. So if you're saying that your object is placed somewhere else, and that object is subjected to the uh, another kind of force, so you can change the direction of these layers by uh, inclining and by positioning this object in some other styles. Like I'll show you. Now I'll place this object at some angle. Okay. Now only one tip of this object is getting touch with this our build plate. So this part is overhang. So we need to support this part. So here we need to generate the support. So you can see when I overhang this uh, tilt this object, then this function will starts working. So I have clicked on this generate sports. Now I'll slice it. Now here you can see uh, sports are created. Now the layers now the layers are inclined to the base edge. These are not horizontally parallel to this base edge. Now these are the inclined to the base edge. So according to the application, you can change this style of printing. So and according to the point of application of the force, you can change the direction of this layers. So how you can get the strongest material, strongest object in this. So how this is kind of print. So uh, I have just make you understand the parameters can be controlled, how the printing parameters can be controlled, how temperature parameters can be controlled. So all these settings have been done in slicing software. After the slicing, we just save this file to the USB, and we transfer this file to the printer. After sending this file to the printer, we we'll start printing. I'll show you how I have done the printing. So uh, here you can see this is our Ultimaker S5 printer, and it has 12 extrusion technique. It works on 12 extrusion. So now here you can see this is the metal filament, and this is the, and it has a diameter of 2.85 mm, and this is a, a, um, brass material, and the material that we are using, and it is has 83% is metal and 17% is a polymer, and polymer is added just to make the metal powder to be adhesive and to be in a form of a wire. So this wire has a diameter of 2.85, and this will feed into this printer to make the object 3D printed. So I'll show you how, first I'll show you how this wire would be fed into this printer. And these wire, the fabrication of this wire can be done in some extruder, and but this is the purchased one, I'll tell you. Now I'll switch on this printer. And this printer is working, the nozzle is moving into the XY, and the build plate has a movement in Z direction. So we'll place it from the back, and before we place it, the wire has to be pass on to this warmer, because the wire is the plastic material, the waste material is plastic, and it has very less quantity, like 17%, so it becomes a brittle material. So until or unless we won't heat this wire, it will break in some many parts. So we need, before we feed this wire to the printer, we need to pass on this wire to this warmer, and the warmer temperature should be around 60 degree, so that the wire can be the making the loosen up. So here you can see the temperature, and we will just place it. This is the bracket of this, and this bracket is also a 3D printed bracket. Here I already hanged it, and we just passing the wire through this warmer, and this wire is after this passing, we'll pass it this through feeder. This is the feeder 2, and this is the feeder 1. After the feeder, we just place it to the feeder, and we just lock it, and the automatic, it will automatically feed to the extruder nozzle. I'll show you how this gonna work. Here you can see we have placed that wire on the feeder. Now I'll go to the printer setting. So on the feeder 2 I have placed it, so I'll select the 2 part. This is the one, and this second one. So I'll select on the second one. This is our nozzle head, and this is nozzle AA 0.4 mm. and this is CC 0.6 mm. Because why 6 CC? Because we're using the metal wire to print, so we need to change the nozzle. That's why I have used this CC 0.6. And this print head has the movement in XY direction. Now I'll gonna select the wire material. The material that bind the metal powder is PLA. So we need to select here PLA. We already placed the spool in the back. Now I'll confirm it. Now here I'll select the PLA material because the pasting material is PLA. The binder is PLA. So I'll select the PLA material. Now I'll confirm it. So we have already inserted the material to the feeder 2. We just gently push it. Confirm. Now the feeder 2 will start rolling and feeding the wire to the nozzle through this pipe. First, it will preheat the nozzle so that material can be extruded out, and it can be checked out whether the nozzle is working or not. So here you can see the wire is coming and it is going through this nozzle, and it will start depositing the material too, because the nozzle is already preheated. Here you can see the wire is automatically extruding out because the feeder is continuously pushing the wire. So now you can confirm it. And this is the uh, glass type bed, and it has the variation of temperature is from normal temperature to around 150 degrees Celsius. Now we will place our USB to this printer, and we'll select the file to print. Now here you can see this cube, and we'll just print, select this, and it will tell you how much time it will take. This 1 hour 15 minute, and the material type is tough PLA. And the wire approximate the wire how much meter will be used. 1.32 meter will be used. Now before printing, it's just saying this, the PLA, it does not match with the printer. Why actually this printer is Ultimaker S5, and it always, every time it saying that use the PLA material from the Ultimaker brand, if we are using the some other brand, it will show this message. So just ignore it, and it will prepare itself. Like from a nozzle, it will automatically level the bed according to the nozzle. So it will take around 30 minutes before the print, because every time it will start auto leveling. Here you can see it just touch to the bed and start. On each and every point it will touch to the bed, and uh, it will auto level this bed to according to the nozzle. Here you can see how it is getting leveling. Now this is the first brim part is start printing. After the brim part, the nozzle will print the object. So here we are printing from the nozzle 2 and nozzle 1 is free. So after some time, we'll just check it out. You can see how this printing head is moving in XY direction and bed is moving in Z direction. So the in Z direction, you can see the movement of the bed is controlled by through this screw. So this thread of the screw is very important. How precisely the thread of the screw is designed. So how much it has to be up and how much it has to be down. The this the error of this is controlled by this precision of this screw, and the all the movement of this these print head and the bed is done by this stepper motor. Now here you can, after some time, we can check it out. The printing has been done. Now we will remove this part. Here you can see this binder material is PLA. So here you can notice the bed is right now it is heated. If you in heated you will remove this material PLA, it won't get removed because in heating position the PLA is more strongly adhesive to the glass. So if you want to remove the PLA material, you have to wait till it cool down. But this is opposite to the ABS material. For ABS material, you have to remove during this printing. Now I have removed this material from the build plate. Now here you can see this material is 3D printed, and it has 83% metal and 17% polymer PLA polymer as adhesive. So this part is not enough strong, so we just need to remove the polymer part. For removing the polymer part, we need to do the sintering. So we will just start the sintering process. You can check it out, the finishing of this printing. This part is very smooth because the base is we have put on the glass plate. That's why the base is very smooth. So our crucible is ready, and we just place the crucible. We just place this object into the crucible. Before we place the object in the crucible, we just need to create an environment first. And the environment I am creating here is aluminum oxide, just to not to oxidize the our object. So first we put a layer of aluminum oxide. After putting the first layer, I'll place the object, and I'll keep one layer around the object is aluminum oxide. So after covering the object from aluminum oxide, now I'll make the object with another layer, that is of carbon layer. So we'll take a coila and we'll crush it into the small particles, and we'll spread it over this aluminum oxide into the crucible. And these coals are spreaded over the aluminum oxide. Just uh, the direct heat of the oven or the sintering oven uh, won't disturb the object. So it will get first, it will give heat to the coal, and the coal heat will transmit to the object. So we'll cover it very gently. After covering it, will place this object we will place this crucible into the our centering oven. And this is our centering oven, and this has a capacity of ranging from normal temperature to 1400 degrees Celsius. We'll place it. After placing, we just need to create a heating cycle, uh, on which temperature we need to just hold the temperature for how many hours. So this is the experimental part that I have done. Lots of experiment, then I have achieved the final temperature cycle. Now we'll close this gate. After the closing, we will set the temperature cycle through the PID controller. This oven has the facility of PID controller too, and this I'll tell you this. The oven has the facility of vacuum sintering and the other environment printing too. Like if you want to create want to done the sintering in some argon in ideal gas, you can uh, this has the option through this pipe, and we can create the environment too. Now we'll switch on this. Now through this PID control, we'll set the temperature. Here you can see there are two needles, one for the voltage and one for the ampere. Now here you can see 0 to 120 degree. I have set for 1 hour. Means in 1 hour it will raise from 0 degree from the room temperature to 120 degree. And after 1 hour, it will take another 1 hour from 120 degree to 240 degree. And after this 240, in another hour 1 hour, it will 240 to 360 degree in 1 hour. So accordingly I have set these temperatures, and 360 to 480, 360 to 480, and 480 to 600 degree in 1 hour, 600 to 720 1 hour, 720 to 815 1 hour, 815 to 840 1 hour, 840 840 to 1 hour, and after 870 it will, when we it reach to the 870, it will stand for 1 hour, and after these 1 hour, it will, the program will end, and this total hour taking of centering is 10 hour. So we'll set this temperature, and minus 121 means it the program will gonna end. So now I have all set this. Now I'll run the program. So here you can start see this 0% to 100%. There is light blinking, and it shows that it is started. Now that it is increasing, here you can see the SV value and PV value. SV value is uh, it is starting value, means it will set the target value, and PV it will achieve the value. So after this, uh, I'll show you how this. Just a second. Now we have already set the temperature, and we'll start the program. After this, when the 10 hours program will reach to the final, and we'll wait for some time to get it cooled down, and after 2 3 hours of completing the cycle, we will bring the object out from the centering oven. I'll show you. So here you can see the bar is continuously increasing. It means the cycle has started. Machine, and this is the final the part uh, that is centered from the centering on. Now we will start this, means we will finish this post, we'll start the post processing process, so that we will remove these carbon material from the surface of this object. After the post processing, I'll show you how it will look like. This is a post processing process is going on. Obviously, the dimension we have set 70 but the final product has some what around 17 to 18 2 will be lost out due to this when we remove the PLA from this. So here you can see our final printed and post processed part. and you can see the finishing too. So this is how we have done this uh, 3D printing of metal through metal fuse filament fabrication process. So this is all about the fabrication of metal printing through metal printing. So if anyone has any query, you can ask me. I have done. So if anyone has some query, you can ask me.
Sir, one question.
Yes.
During this layering process, can we go for some different metal or any oxides? Like I want to coat some metal oxides, high temperature metal oxides, along with this some graphene oxides, reduced graphene oxides powders.
Okay.
Be done in layer wise with a thickness of around 5 mm.
Means you want to add some layers to the
Yes,
object.
yes, sir.
So through centering you cannot add, but in printing you can add those layers.
No, sir. I am talking about printing.
Printing you can add those layers. On no, you cannot stick to the one material. It has the liberty of using any type of material.
Sir, is it possible in slide itself to do?
If you bring it your material, we can provide the
Okay,
facility.
sir. Okay, the materials I will provide.
Yes.
Okay, thank you so much, sir.
Okay.
We'll be in touch.
Any other
Okay, sir.
query? I think there is no query. Pardeep sir. Just wait for a minute. I'll bring people.
Okay.
अनुज सर.
हाँ जी हाँ जी हाँ जी
सर
थैंक यू.
हाँ जी हाँ जी ओवर हो गया सर लेक्चर.
ये स्क्रीन कर देंगे सर.
हाँ सर ओके सर.
Okay, everybody. Thank you very much for a very informative lecture, and it's a practically oriented. First of all, I would like to thank Professor Pardeep Gupta sir for giving basics about the 3D printing for polymers, and then followed by Praveen Kumar sir. He has given a good demonstration at how step by step we can work for the 3D printing. Thank you very much. Thank you. So we'll see you the next session after 15 minutes at 11:30. Thank you.